Hello everyone. I want to go over the answer key to elements, molecules, and compounds mixtures from last week. So on slide 2, we have here the molecule of elements as well as compounds. Now, so you'll see with the element that why it's an element is because it's two of the same color, and that represents an element. An element, remember, is made up of only the same kind of atom. Whereas compounds are made up of two different kinds of atoms, two or more different kinds of atoms. So you can see here we have our green and our blue that makes up a compound because they're two different colors, two different atoms. This we have the water molecule. We have our two little hydrogen here and our big oxygen here. Again, two different kinds of atoms chemically bonded together. Therefore, it's a compound. And then we have, once again here, an element and then different elements surrounding it. So the three here would be an example of a compound. Now technically this here is an example of a mixture of elements because you do have a red element and then you have a blue element hanging out in the same space. I know for some of you I put on here double check this, and then I realized later that was really your only option. Some of you are really creative and you grabbed some from the slides below here to put in here, and that was a really great idea. So good thinking. The next page we have mixtures. Now remember, a mixture is basically any material that's hanging out in the same space but not chemically bonded. So here we have an example of a mixture because we have two different elements hanging out in the same space. Here we have two different kinds of compounds hanging out in the same space. And once again, two different kinds of elements hanging out in the same space. So these would all be mixtures here. Whereas for pure substances, you'll notice that really the major difference is that they're the same throughout. So if it's a pure substance, it is made up of only a compound or only an element. It has to be the same throughout in order for it to be a pure substance. So water is a pure substance. Sugar would be an example of a pure substance because it's all the same throughout. Salt would be an example of pure substance, sodium chloride. And then lastly, a lot of you did very well on this. I was impressed. So we have, once again, a mixture of elements because they're the same color, only one kind of atom. More than one element, though, hanging out in the same space. For compounds, once again, we have two different compounds hanging out in the same space. Now here, this was kind of probably tricky. We had to really analyze it, where you had your compounds, more than two different kinds of atoms bonded together, and then an element, just a single kind of atom hanging out in the same space. So therefore, it's a mixture of elements and compounds. So I hope that was helpful. And now I want to go through the second sheet. And so I really want you to focus on this slide right here. And you'll notice that for a solid, the particles are closer together. In these energy lines here, you'll see that there's not as much energy as there would be as in a solid or gas. And they have some kind of shape to them, because remember, the definition of a solid is that it has a definite shape and a definite volume. So, which we know if we took a marble and we put it in a jar, it would not affect the shape of the marble. It would not affect the volume of the marble. And then when we move on to liquid water, you'll notice that they're much looser and they are not in that rigid fixed position like solids are. And that this is what gives liquids its property of having an indefinite shape. It's because they're not positioned in that fixed position like they are with solids. But they do have a definite volume. Notice how these molecules here of water are not filling up the entire space because they have their own volume. Now if we compare that to a gas, you'll notice there's a lot more spacing in between the gas molecules, and that They don't have their own shape. They're taking on the shape of their container. We say an indefinite shape. And they also don't have their own volume. They have an indefinite volume. They take on the volume of the container that they're in. And we know if we lifted this cap off, what would happen to those gas molecules? They would escape out and take on the volume of the room that they're in. So please email me if you have any questions. I hope this was helpful, and take care and have a great week.